lesson is the first lesson in the three-dimensional or solid geometry unit. We're talking about naming solids. The homework that goes along with this is page 2-4 in your homework packet. All right, you are on the first page in your notes. All right, we're going to fill in these blanks, fill them in as we're going. Solids are objects that do not lie in a plane. They have length, width, and height. Now, this is kind of hard for me to show on a board when you can't see me. In class, I'm going to be showing you solids. They're cubes, rectangular prisms, spheres. Okay? A prism is a solid with two congruent bases. The lateral faces are parallelograms. And again, I'm going to be showing these in classes. A pyramid is a solid with one base. And the lateral faces are triangles. A cylinder. I'll probably spell that correctly. Is a solid with two bases that are parallel congruent circles. A cone is a solid with exactly one circular base. And one vertex. And again, I'm going to show these all in class. A polyhedron is a solid whose faces are polygons. A lateral face is any side that is not a base. An edge is where two faces meet. Or it could be a face and a base. A vertex is where two edges meet, and skew lines are two lines that do not intersect and are not parallel. They are in different planes. And again, I'm going to be showing all of this in class. It is easier when you see an actual shape. All right, first of all, that's a pyramid. It's got a base and triangles, one base and a triangle. In the figure below, describe the base, the name of the figure, and the part that is labeled CD. So, the base of this pyramid is right here. And we're going to call that a rectangle. You name a pyramid and a prism according to the shape of its base. So this is a rectangular pyramid. If it had a triangle on the bottom, you'd call it a triangular pyramid. If it had a hexagon on the bottom, it would be a hexagonal pyramid. CD is what we call, CD is right here, it is called a base edge. If I gave you EC, that would be called a lateral edge. And if I said E, that's a vertex. Name a pair of skew lines. So, skew lines are two lines that will never intersect, but they are not parallel. So, I could do line EA And I could jump down here in BC, segment BC. Those are two lines that will never intersect, but they are not parallel. Now, if I did, and I'll change color here, DC and AB, those are parallel. They're not skewed because they're in the same plane. They're both on the base. And again, I will be showing this in class on actual solids. It makes it easier. Now, take a look at this. This is a picture of a prism. It is a triangular prism. Because here's the two bases. The bases are triangles. And we know that it's a prism because there are two of them. And again, you name a prism and a pyramid by the shape of their base. So this is a triangular prism. Let's get two skew lines. And again, skew lines are lines that never intersect, but they're not in the same plane. So I'm going to do AB. And I'm going to go over here and I'm going to grab this one, segment DF. They would definitely be skew because they are not going to ever intersect, but they are not parallel. Now, a pair of parallel, let me change to pink. I could do BC is parallel to EF because they are in the same plane. They don't intersect, but they're in the same plane. All right, describe the base, name the figure, and name of the part labeled pH. All right, so let's take a look at this. Let me count the sides of the base. 1, 2, 3, 4, 5, 6, 7, 8. That's an octagon. So, the base is an octagon. So this will be an octagonal prism. Because it's a prism, it's got two bases. And name the part pH. Here's pH. That is a lateral edge. These are the bases. These are all the lateral bases. Base with an F. Okay. 2. State whether each pair of line segments is intersecting, parallel, or skew. So, IJ is right here. And F and E. Where's ME? ME is back here. Now remember, this is a 3D shape. They would be skewed. Because they're never going to intersect and they're not parallel. Let me change colors here. Segment OG. OG is right here. And segment IA. Segment IA is right here. Those would be parallel. Because I could slice a piece of paper right down through that shape, and those two would be on the same plane. So they are parallel. Nets are called shape jackets. A shape jacket is a flat 2D that can be folded to create a 3D. A net is basically the surface area of a shape. Okay, so if I unfold a net, a prism is going to have two identical prisms. Have two identical bases connected by rectangles. The nets for prisms have two bases which look like tabs and lots of rectangles. Pyramids have one base connected to a point by triangles. Nets for pyramids sometimes look like stars. All right, let's take a look at these. Now, again, if I would fold this up, this would be a rectangular prism because it's got two bases connected by a bunch of rectangles. There's no such thing as a square prism. So these two things, I agree, they do look like squares, but we still call it a rectangular prism. This thing, I would call this a square pyramid. Now, you could also argue, well, you're not 100% sure that that's a square, so you could call it a rectangular pyramid. Either one of them would be right. Let's count the sides here. 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagonal pyramid. All right, this one has two bases. This is a triangular prism because it's got two bases. Here we go. Here's our base. This is a triangular prism. Not prism, pyramid. Because it's only got one base. If I fold this up, I will have a rectangular prism. Here we go. 1, 2, 3, 4, 5, 6.